Welcome to 9.7 Polar Graphs. This is going to be the second and final section that we do from Chapter 9. So a little bit of work on polar and rectangular from 9.6, and now we're just going to see what these graphs actually look like. So we have our first one, r is equal to 4 sine theta, and I'm going to do the exact same thing that I would do if I was trying to graph something for the first time. I would just make a table. So based off of the equation itself, the way that it's formatted, I want to plug in thetas, just because all of the math is on that side, and I'm going to get r's out of it. So I'm just going to set up myself a table here, and let's start plugging some values in. Okay, so I made my table fairly large because I'm going to plug in all of the radians that I'm familiar with from the unit circle all the way around, not using any of the sum and difference or the half angle stuff. I'm just going to stick with the plain old pi over 2's, pi over 3's, pi over 4's, pi over 6's, and then the pi and the 2 pi. So let's start working our way around. So I think the first place I'm going to start in is 0. Seems like a good spot to start for me. And I'm going to leave a little bit of space, and I'm going to do my work over here. So I'm going to do 4 sine of my angle, which is now 0. Well, I know that sine of 0 is just 0, and then 4 times 0 is 0. So it looks like I get a point 0, 0. I'm just going to go through and proceed and try to fill these in. So let's do pi over 6. We'll do the same thing, 4 sine pi over 6. So your knowledge of the unit circle is really going to come into play here. So sine of pi over 6 is going to be a half. 4 times a half is 2. So I'm going to go ahead and just finish my first quadrant, and then I'll come back. Okay, so I went ahead and filled in and did the math on the rest of the stuff in quadrant 1. You see when I plugged in pi over 4 and pi over 3, I got radicals. Well, I need to be able to have a better idea of where these things are located because I am going to graph them on a polar graph. So I just went ahead and typed them into my calculator, and I'll figure out what those approximations are. So 2 root 2, this is going to be approximately 2.8. Now, normally you know that we've been rounding things or truncating to 3 decimals. But since I'm only doing this for the sheer purpose of being able to graph or get a decent sketch, I'm not necessarily going to go out to 3 decimal places, because when I decide to graph it anyway, I'm still going to chop it off at about the first decimal place. So this turns into about 3.5, or pretty close to it. So I'm going to go ahead and continue on with the second quadrant, just kind of working my way around the circle, and I'm still going to do the exact same thing. So I'm just going to go ahead and fill them in and see what we get. So I'm going to fill in the second quadrant, the third quadrant, and the fourth quadrant, and then we'll use these points to help us graph. Okay, so I finished filling in my theta r table for all of the increments around the unit circle in terms of pi over 6, pi over 2, pi over 3, pi over 4. And you'll notice that there is a pattern here. So because of the way that sine behaves in the unit circle, anything from 0 to pi is going to be positive. So that's this left table here. So those are all going to give me positive radii. Whereas on the table on the right, because we're talking about theta that is, for sine, is going to be down or negative from pi to 2 pi, we're going to get negative radii for all of those. Well, we know back from 9.6 that if you end up with a negative radius, all of these points, excluding that last one, so let's get rid of that, because of the 0, it doesn't behave the same way, there's nothing wrong with 0, all of those we're going to have to shoot through the pole. So when we sketch these, we're going to have to shoot. So I'm going to take these values that I have, and I'm going to use them on my next page. So make sure that you have all of these written down, since we are going to use these, and then let's flip to the next screen. So here we have this nice polar graph all set up for us. And since this is in pi over 12 increments, I went ahead and labeled all of the pi over 6's, 4's, 3's, and 2's for us. So we knew exactly where we were going to be graphing. So let's go ahead and start. So I think I'm going to do this in See, I think I used red previously to represent the true location of these things, so that's what I'm going to do now. So I'm going to use red, and I am not going to plot or mark anything with a negative radius. I am going to hover where it is, and then I'm going to shoot through 180 degrees or pi distance through the pole and just plot its positive radius on the other side. So let's go ahead and start plotting some points here. So I know at first this can look a little confusing, but remember, if you keep it organized, try to use polar paper itself, so if you make a mistake and you erase, it doesn't get rid of the entire axes for you. So my 0, 0, well, that should be fairly easy. There's nothing too exciting about that. So there's my 0, 0 point. Then at pi over 6 comma 2, so I think with the positive radius we shouldn't have an issue. So pi over 6, go to the second ring and plot the point. So there's my pi over 6, second ring. Then my pi over 4, I went through and I figured out what that decimal was for the 2 root 2. And that was 2.8 approximately. So at my pi over 4, I'm going to go out to close to the 3, and then I'm going to plot a point right there as well. So there's my 2.8. So I'm going to go ahead and just plot all of my positive ones, and then I'll come back and we'll do the negative ones together. Okay, so I have finished plotting all of my points from 0 to pi, and these are the locations that they've given me. Now I'm going to go ahead and do the negatives, and I think I'm going to go ahead and grab a different color just so we can see that these are going to be a little bit different. So now I take a look at my first one, which is going to be 7 pi over 6. So I'm down at 7 pi over 6, and I guess I should mark it so you guys can see it. So 7 pi over 6, negative 2 would be here. However, I don't want to be at a negative radius, I want to be at a positive radius. So I'm going to take this point and I'm going to shoot it through on the exact same line, and lo and behold, I land on one of the other points that's already there. So let's put a purple on top of that red. I'm going to do the same thing with the 5 pi over 4. So 5 pi over 4 ended up being negative 2 root 2, and 2 root 2 is 2.8. So if I go to my 5 pi over 4 and I go out to negative 2.8, it's about there, I'm going to do the same thing and shoot through. Notice that it lands again on top of one of the red points. So I'll just put the purple on top. Let's do the same thing with the next one. So the next one is going to be the 4 pi over 3, which is negative 2 root 3, and 2 root 3 was about 3.5. So down here I'll go out to about 3.5, mark it. Notice that all of these marks aren't actually part of the graph because I'm shooting and it lands again. If we go through and continue the exact same thing that we've been doing, so the 3 pi over 2 is going to be negative 4, notice it's going to shoot through again. If we go through and check all of the points, and you do want to make sure you check all of the points, we have the exact same situation happen with all of the other ones. So every other one with the negative here and here has the exact same situation happening with all of the other ones. They get shot through. So this one looks a little low to me. Let's move that up a little bit. They all get shot through to the other ones already. Here and here. Then as I finish my loop, 2 pi, I get 0 again. So if I connect the dots on that, just the dots, not the marks, then we'll have the graph for this function. So after connecting the dots, what I am going to get for this graph looks like a circle. So let's move on and try another one of these. So remember, what we're doing here is we're creating a theta r table. We're going to plug in all of the thetas all the way around the unit circle, and we're going to evaluate r. So try to find out what r is for each one of those. And then we're going to go through and plot them. So I'm going to move on to the next slide. The equation here is 1 minus 2 cosine theta, and I'm going to do the exact same thing that I did before. So let's list the points. So I went ahead and finished all of the points, and you'll notice that I wrote down the first couple of them showing my work off to the side, and then after that I was able to establish a pattern. So remember that this is a cosine graph itself. So because we're talking about cosine, our knowledge of the unit circle, the cosine values are going to be positive in the first and fourth quadrant. Because of the equation itself, we're going to do 1 minus 2 times that. So to do that multiplication and subtraction, we're going to end up with either 0 or a negative number. So in a couple of these locations, we're going to have to shoot. So in our first set here, where we get the negative values, we're going to shoot there. And when we get the negative values again. So those are the values in the first and the fourth quadrant, except for the pi over 3s. The pi over 3s are going to give us 0. So in those red locations, though, we're going to have to shoot. So I'm going to do the same thing that I did before. I'm going to have these points recorded so that when I go to the next slide here, I can go ahead and just start setting stuff up with my graph. Alright, so here we are again. Here's my polar graph. I'm going to go ahead and just start plotting my points. So I originally already start out with the negatives. So I'm going to do the same thing I did last time. I'm going to deal with the purple. Should probably do a lighter color. Let's do with light green because I want to mark over it in red if that is the case. So if they lay on top of each other. Alright, so I've got a 0, so my radian of 0, and I've got a negative 1. So typically my 0, 1 would be here. But that's a negative radius and I don't want that. I want a positive. So I'm going to shoot through and I'm going to plot the point. So there's my 0, negative 1. Now moving on, I've got my pi over 6, and my pi over 6 is also going to be another negative. So I'm going to go out to pi over 6, and I'm going to mark where negative 0.7 is. Well, it's going to get a little tight in here. So if I go to my pi over 6, negative 0.7, it's about right there. And I'm going to go ahead and shoot through the exact same distance onto the other side and plot that point. So there is my pi over 6, negative 0.732. I'll do the same thing with pi over 4. Pi over 4 is even closer because it's negative 0.4. So I'll do the same thing. I'm going to mark it there, but I'm going to shoot through and actually plot it here. So I'm going to go ahead and continue and graph some more points. Once I get to my negatives, then I'll come back again. So let's fill in the positives and see what happens. Remember that the x's are not going to be connected. It's the points that are actually going to be connected to create the graph. Okay, so I just finished plotting. My last point here was the 4 pi over 3, 2. So this point here, 4 pi over 3, 2. Now I'm going to do my 3 pi over 2, 1. And now I'm going to get to my negatives again, or excuse me, 5 pi over 3, 0, which basically just puts me right back here in the middle. Now I'm at 7 pi over 4. So now I'm at 7 pi over 4, so I go down to my 7 pi over 4, and that is going to be at negative 0.4. So it's going to be about right there. But it's negative, so I'm going to shoot through to get to my negative 7 pi over 4 at about 0.41. Then I'm going to do the same thing with the 11 pi over 6. 11 pi over 6 would be at negative 0.7, so about right there. And I'm going to shoot that through as well. Here. So what I have here is I have these points on the left-hand side that are going to be connected, and you want to connect them in the order that you plotted them. So sometimes connecting as you go is pretty wise. Other than that, you do have to remember the order. So I started at the 0, 1. And then I connect here, then I went to the 0, then that 0 came all the way out and connected with all my positives, and then I looped back into the middle and I shot through my points. So there we have our graph for r is equal to 1 minus 2 cosine theta. So again, remember, if you have a negative radius, you got to shoot. You might want to put little marks or X's and then shoot through and plot those. And I think that's it. If you have any questions, make sure you ask in class.